Hi everyone, and welcome to our video of using SOH CAH TOA with our inverse trig compositions, but this time around we have variable expressions involved. Okay, so if you're going in order, the previous video was the same deal, inverse trig, but it had numbers. But it doesn't change the strategy, so it doesn't matter what they put in these, we're still just going to create a right triangle. So we can still break it down and say, so it does say write each expression as an algebraic expression. So that means they want it in terms of just x. Assume that x is positive and the given inverse trig function is defined for the expression in x. Okay, so that way we can't just say, oh, it's probably undefined. Nope, not this time. All right, so what we can do is still just say, well, the tangent inverse of x squared is some angle. So again, inverse trig is always some angle. And then we can instantly rewrite it with our inverse property to say tangent of theta is that x squared. Okay, and then now we're going to use SOH CAH TOA. It might help to put a 1 under there because we can now make our right triangle. There's our angle theta. Tangent of theta equals opposite. So that's the opposite. This is the adjacent. So opposite x squared, and then the adjacent is 1. And then let's mark those. Okay, so the adjacent, opposite, we need to find the hypotenuse. Okay, so let's find the hypotenuse. The hypotenuse, we can use Pythagorean's theorem. So 1 squared plus x squared squared equals the hypotenuse squared. Well, 1 squared is 1. X squared squared is x to the 4. And then we want the hypotenuse solved for. That means we will do the square root on both sides. Again, for good habit, plus minus, but we're choosing the positive based on all of this information that they're telling us up there. We're going to assume that everything's going to stay positive. Okay, so now we do have the hypotenuse, and it is just the square root of 1 plus x to the 4. Okay, so square roots do not get along with most things. That does not simplify. So don't say, so mistake alert, don't do this. Don't say, oh, square root of 1 is 1. Square root of x to the 4 is x squared. Don't do that. Nope, never do that. Okay, and we can easily see it with numbers. The square root wants to do the order of operations. So this should be the square root of 25, which becomes 5. If you did square root of 9 to get 3, and then the square root of 16 to get 4, and then added them, well, we don't get 5. We get 7. Okay, so that means there's something up, there's something wrong with that. Okay, so what's good about square roots is you pretty much just leave them alone. Okay, so once you get it, you just leave it, just write it all the way out, and it's good. All right, back to the original statement. Okay, so in our original statement, this is still sine. That in the purple box is theta. So we have sine of theta. And then now again, we use our triangle. It's down here. Okay, back to our triangle. We'll even put an arrow because we're pretty much done with this problem. Sine of theta, SOH CAH TOA, opposite over hypotenuse. So the opposite is x squared. The hypotenuse is the square root of 1 plus x to the 4. Now, often they leave that square root alone down below. So if it's a variable expression with a square root, they often leave it. But if we do need to rationalize it, it would be to multiply the top and bottom by square root of 1 plus x to the 4. And what that would do is, let's write that final answer just right below. It would be x squared and then square root 1 plus x to the 4 over just 1 plus x to the 4. Okay, so this is the other way to write it. But often they only rationalize numbers down there. So for instance, like this one had a square root of 2. That's a regular old number. So that's when they like to rationalize the denominator. If it's a variable expression, I believe this first one is mostly the one that they would actually prefer. Okay, so there's some strange rules with math that we follow sometimes, but then ignore the others. So that square root's okay. Anyway, they're both the same. All right, number 2. We have arc cotangent. Okay, not a big deal. this is still just some angle. Okay, so that's just some angle. So that means the arc cotangent, which I'm going to write as cotangent inverse, remember they are equivalent, of 4 over the square root of x squared minus 16 is some angle theta. And then we'll use our inverse property to say, well, cotangent of that theta is 4 over the square root of x squared minus 16. And then we could even say, well, I don't like cotangent that much. I'd rather see tangent. Tangent of theta, now we could flip the fraction. So we would have the square root of x squared minus 16 in the numerator and 4 in the denominator. And that might make it a little easier. So now it's kind of similar to that first one. This is still an opposite and an adjacent. And we can now set up our right triangle just like before. So here's our theta. We have the opposite side is the square root of x squared minus 16. We have the adjacent side is 4. And then we again need to find the hypotenuse. Okay, so they could give us different trig functions besides tangent here. So as long as you fill out your triangle with those words and place the things in the right spot, you'll be fine. Okay, but Pythagorean's theorem will tell us 4 squared plus square root of x squared minus 16 squared is the hypotenuse squared. 4 squared is 16. Square root of a square cancels, so x squared minus 16th left equals the hypotenuse squared. 16 minus 16 is 0, so we're left with x squared equals the hypotenuse squared. And now we can square root both sides. Again, for good habit, plus minus, but we're going to only take the positive. So that way we know, oops, I didn't do that right. I was going a little too quick. It is just x. Let's go ahead and write that down below too in that problem. So square root and square cancel. So x is the hypotenuse. Okay, so our hypotenuse is just x. Okay, so cool. So it looked worse than probably what it really was. It is just x, how nice. Okay, and then now, one more time, back to the top. We have cosecant of the angle theta. Again, that whole purple box thing is just an angle. And then I would say, well, let's do sine of theta first, just down below with our triangle. So we still have our triangle. Sine of theta is opposite over hypotenuse. So square root of x squared minus 16 over the hypotenuse x. And then now we can solve for cosecant. We just flip this fraction, x over the square root of x squared minus 16. Like I said in the last problem, variable expressions with a square root in the denominator, they often don't care about. So I'm going to leave it as is right here. So that's my final answer. Okay, so that's how we break these down. So again, if it's a number like these, or if it's a variable expression like these, it doesn't change the strategy. Just go through it the same exact way. Just don't let those letters freak you out. Okay, so that's it though. Thank you for watching. If you have any questions, please let me know.